All right, so an ionic equation. I decided to go ahead and break up this lecture just because this is kind of a separate entity. This is all about ionic equations and net ionic equations. So far, we've been looking at writing overall and total chemical equations. So we've shown the complete formulas of the reactants and the products. That's presented right here. Okay, we showed the state that they're in of the reactants and the products. Now what we're going to do is we're going to give a better representation of what's taking on in that solution. And what that looks like is a silver ion that reacts with a nitrate ion, and that's in the same solution as a sodium ion and a chloride ion. Now what's going to happen when these different substances come in contact? Well, silver and chloride, well, they're going to precipitate out and make that solid. NaNO3, on the other hand, well, those are still going to exist as independent ions. Okay, so this right here is an ionic equation. It shows all of the ions in the reactants and in the products. Which ions are present and which ratio, or what's the ratio of those ions to one another. Now, a net ionic equation is a little bit different. When you look at this net ionic equation, what we've got are a couple of different things. So this lists out everything. Here's our reactant side, and I'm underlining all the different components that are on that reactant side, and then all of the products that we get. Now, there are a couple of items that are highlighted in green. I'm putting little stars above them. Well, those are our spectator ions. Arguably, they do nothing in our overall reaction. Now, what we can do is we can remove them because they contribute effectively zero to the production of our product. And our product is silver chloride, AgCl. That's our solid. So the difference between an ionic versus a net ionic equation is simply these spectator ions. The net ionic equation does not have those spectator ions that the ionic equation does. Now here's an example of an overall reaction. And so this is our ionic equation. What we need to do is we need to distill it down to our net ionic equation. Okay, so whenever you're presented an ionic equation, essentially what you want to do is you want to find what is your product. And I can see right here that my product, or our product, is this calcium sulfate, CaSO4. That's our solid. Okay, so then what I want to do after that is I want to go back to the components that are involved in that. Well, if I look at my reactant side of my equation, I need to find calcium and I need to find sulfate. Calcium is right here and sulfate is right here. So to write my net ionic equation, I simply write Ca2+ aqueous plus SO4 2- also aqueous yields CaSO4 solid. That's all there is to it. Now this right here is the sort of problem that you can expect to see. This is a problem, well, you can also expect to see the previous, but this is a good representation of here's your entire reaction. Now go to an ionic equation, then to a net ionic equation. So all that we're going to do is break apart all of our aqueous substances. We're going to say 2 Na+, and I'm going to skip writing the states just for the time being, but to do it properly, you would include the states. So I'm going to say 2 Na, then I'm going to say 2 OH. And I want to say that because of the fact that this 2 coefficient is in front of NaOH, therefore it applies to Na and OH. Now, how did I know that it split NaOH rather than NaO and H? Well, I know my polyatomic ions, and I know I know that I'm working with ionic compounds, so I want to figure out where those ions are and split it accordingly. So the next one will be plus Pb, and that's a 2 plus 2 NO3 minus. This is going to yield, now here's my product, PbOH2 and I'm going to put a solid there because that's going to be important, plus 2Na plus 2NO3 minus. Okay, now again, all that I really need to do is I need to track down which are my reactants that, well, I actually find in my product. And I'm going to switch to my highlighter, and I'm simply going to highlight them. I am looking for PbOH2. So I'm looking for Pb. And I'm looking for 2OH. So what I've written above, or what I wrote right here, is my ionic. I wrote that in yellow. That's kind of tough to see. Now I'm going to write over that in red. Now what I need to do is I need to write my Ni, or my net ionic equation. So all that I'm going to do is write Pb2 plus, I'll put the AQ down here. I'll put the states now because it's a smaller number of things to worry about. 2OH minus AQ yields PbOH2, and that's a solid. Okay, so that's everything that I need to do. That's my net ionic and my ionic equation. And one thing that is worth noting is, well, ask yourself, is my net ionic equation balanced? It absolutely is. I have 2OH here. I've got a 2 as a subscript outside of my parentheses for my lead hydroxide. Well, I hope this was helpful. This is something that requires some practice. I would say the most important thing is to get from, or the step one in this process is to get from basically your molecular reaction to that ionic reaction. Because once you can get to that ionic reaction, well then you just remove things to write that net ionic equation. So I would say from point A to point B is harder than from point B to point C of the net ionic equation. Keep practicing on it. I'm sure you'll do great. Well, thank you very much. Have a